In this video, we will practice to write the name of KCl and to write the formula of potassium chloride. To write the name of KCl, name first the metal or the cation as it appears on the periodic table. And K, it is potassium. Next, name the non-metal or the anion. And Cl, it is chlorine. But we replace the ending with IDE. So instead of INE, change it to IDE. So for the name for KCl is potassium chloride. To write the formula of potassium chloride, potassium is in group 1 in periodic table, that is positive 1. Ionic charge is K positive 1. And chlorine has negative 1 charge. Potassium has the only symbol of K. Next, we have chloride. Here, in periodic table, we cross IDE and write INE. So we have chlorine. And it is Cl. We have metal, the potassium, and chlorine for non-metal. We need to balance the charges. If we look on the periodic table, potassium is in group 1. It has positive 1 charge. And chlorine in group 17 has negative 1 charge. Then cancel out. And give us the net charge of 0. And that makes KCl the correct formula for potassium chloride.
Hi guys, it's me Francesca, and today I'm going to teach you how to write the formula for PbCl2. So first, we need to go to the periodic table and we look up lead. So that's Pb. And we look up chloride, that's Cl. So lead's a metal and chlorine's a non-metal. We have a metal and a non-metal, so that's ionic. And we need to consider the ionic charges on the lead and the chlorine. So lead, that tells us right in the name that it has +2 because of the Roman numeral. So lead's 2+, that's its ionic charge. Then chlorine on the periodic table, that's 1-. Since lead to chloride is a neutral molecule, so these charges need to add up to 0, and they don't right now. So we can use the crisscross method to change the subscripts. Here, to make them add up to 0, we move the 1 here. We move the 2 here. So get rid of the 1 because we don't write that by convention. So remove the charges, and that's the formula for lead to chloride, PbCl2. So now let's check our work to make sure that we got the right answer. So lead we said was 2+, chlorine we said was 1-. So I have 2 chlorine atoms, 2 times the 1 minus, that's 2-. Lead 1 times the 2+, that's 2+. Then 2+ and 2-, that adds up to 0. So the net charge is 0, and we're done. That's it. So the correct formula for lead to chloride again is PbCl2.
To write the name for PbCl2, first we need to recognize we have a metal and then a non-metal. So a metal and a non-metal, it's gonna be an ionic compound. Specifically Pb, which is said, that's a transition metal. So we need to take this into an account as well as when we write the name for PbCl2. So we have this ionic compound with a transition method. We'll use these rules to write the name. First we write the name for the metal, that's lead. Next we write the name for non-metal, that's chlorine, so lowercase c, and then we change the INE to IDE. So at this point we have lead chloride, but remember we said lead is a transition metal. So because it's a transition metal, we don't know the charge. So we have to look at what it's bonded to. So chlorine always has 1 minus ion of charge, and we have 2 of them. So 2 times 1 minus, that's 2 minus. Lead has to be 2 plus for all these charges to add up to 0. So it will give us the net charge of 0. So because we have these 2 plus on the PB, we write a Roman numeral 2 between lead and the chloride. And the name for PbCl2 is Cl2 chloride.
That's it. I hope you learned something today, and thank you guys for watching. Bye!
Good day everyone! I am here to show you a simple tutorial on how we name a binary covalent compound with 3 basic steps. Let's get started. So first, we have to determine its name and its formula. The element of sulfur has a total 3 number of atoms, while the iodine has a total of 8. Second step, we will now base on the atomic number right beside the 2 elements. So I have provided here a prefix chart that indicates the number of each element in a compound. We will now get the prefix of both elements. In naming the binary covalent compound, we will find the prefix number 3, or also called tri, and write it right beside the first element, which is the silicon, just like this. Same goes with the second element. Write the prefix octa, then IDE must be written at the end of the element, just like this. That's it! Now you know how to name a binary covalent compound.
Get the name and formula of ionic compound. Ionic compound must contain metal and non-metal element. Our example is cesium fluoride. CS can be found on the first group of periodic table, while F or fluorine can be found on the ninth group, which is non-metal. The suffix of fluorine was changed into IED because fluorine contains a single negative charge. The formula of ionic compound, the charges must be equal. CS contain positive 1 and F contain negative 1. The formula of CS and F must be written as CSF.
In this video, we will practice to write the name of H3PO4 and to write the formula of phosphoric acid. To write the name for H3PO4, we make use of 3 elements chart. So we have H, P, and O. So it is 3 different elements. So we have H, that what it makes acid, and we have this PO4 group, we call this polyatomic ion. So we will look the polyatomic ion in the table. H has a positive 1 charge, and we have 3 of them. So we will have positive 3 charge here in H. So that means PO4 is gonna be minus 3, looking in PO4 3 minus. And we will use PO4 3 minus. It is called phosphate ion. Let's write phosphate. And we will look in the flow chart. It is end with ATE or 8. So that means we will get the stem of phosphate and replace the ATE with IC. So we get rid of ATE and we will write IC, and we have the name acid. But we need to do small change. Phosphate so we need to put the OR in the name, and that leaves us the phosphoric acid. To write the formula for phosphoric acid, if we look in the stem plus IC, so we have IC here. First, we will write the stem of phosphoric, and that is phosphor. Next, instead of having IC at the end of it, we will write ATE or 8, and that is phosphorate. Second, so look for ion on common ion table. This is PO4 3-. And if we have, or if we fix this phosphorate, we can see the phosphate, not phosphorate. So we will remove the OR in phosphorate. So we have the PO4 3-, the phosphate ion. And we will write H in front of it. So PO4 3- and H in front of it. We need to balance the charges. We have -3 on this phosphate ion and hydrogen +1. To balance this out, we need +3 charge in H to cancel out the -3 or -3. That means 3 hydrogen atoms and cancel out the -3. It gives a 0 net charge. So the formula for phosphoric acid is H3PO4. And that's it.